Okay, so now we're just going to look at dividing polynomials anytime, right? So we've seen how to divide a polynomial if we're dividing by a monomial. And that's great. It's really easy, hopefully, and pretty straightforward. However, what if it's not a monomial? Then, well, it's a little more work, but we can still do it. So what we're going to do is use what's called polynomial long division. In order to do this, we want to kind of see if we remember how to do long division in general. So I want you to take a minute and see if you can remember how to do long division with just numbers, because the process for polynomials is very similar. I'll go ahead and set this up for you. So remember, when we do long division, in this case I'm dividing by 11. That's what I call my divisor. So we set it up like this, where remember this is not a square root symbol, this is the division thing. Okay, so I want you to try to do this, pause the video, unpause when you're ready to discuss. Okay, so the process here, remember, is first I'm going to take the first number here, so 5, and I'm going to try to divide it by 11. So I'm going to take the 5 and divide it by the 11, so kind of off to the side, well, 5 over 11, shoot. 5 is not larger than 11, so that doesn't divide. Okay, so instead of the 5, I'm going to take 52. Well, how many times does 11 go into 52? Well, I know 11 times 4 is 44, 11 times 5 is 55, so it goes in 4 whole times, right? And so that's my division step. So the process is first I divide, so 52 divided by 11 is going to be a whole number of 4, right? It's not exactly 4, but it's between 4 and 5, so I know it's at least 4. So I'm going to put a 4 up here. And now I do my multiplication step. So what's 4 times 11? Well, I just said that was 44. And now we subtract. So what is 52 minus 44? 52 minus 44 is 8. Well, I shouldn't say but. So now I went through a cycle. So I divided, right? We did 52 divided by 11. I got 4. Then we multiplied. 4 times 11 gave me 44. And then we subtracted. And 52 minus 44 gave me 8. So I repeat that again. So now I'm going to try and do, well, what is 8 divided by 11? Well, shoot. Again, 8 is not bigger than 11, similar to up here, so that didn't work. So when I did this subtraction, there is nothing here. Right? So 3 minus 0 is 3. So this comes down, and now I'm going to take 83. Actually, I'm going to use green, make this color coding better. So then we're going to do 83 divided by 11. How many times does 11 go into 83? 11 times 7 is 77, 11 times 8 is 88, so I know it goes in a full number of 7. So that was my division. Now I'm going to multiply again. So 7 times 11, we just said is 77, and now we are going to subtract again. So 83 minus 77 gives me 6. I would try to divide again if I could, but 6 doesn't divide into 11, so I'm done. So my answer is going to be 47 plus 6 over 11. And just to show you, if we did 523 divided by 11 on our calculator, well, what do we get? Well, we get 47.545454 ... right? And so that's the 47 right here. And 6 over 11 is that decimal. So it's 47 plus this decimal is the result. Now you may also remember when you first learned division that you called this the remainder. So 6 is the remainder. It is still the remainder. However, now we want to write our result in this form. So let's look at this with polynomials, and this will hopefully make sense. Okay, so here I want to divide these two polynomials. The very first thing is the setup. So I'm going to do x squared plus 3x plus 2 divided by 2x to the fourth plus 3x to the third plus 0x squared plus 5x minus 1. Now, you may notice that I put in this 0x squared. That's crucially important. Whatever the highest degree term is that we're dividing, we need to account for every single degree below that, even if it's not listed. So since I started with x to the fourth, I need to have an x to the third, x squared, x, and then a constant term. That'll be important in the division process. Every once in a while, it won't make a difference, but you don't know that until you start, so you need to put it in there just in case. Okay, so now we're going to actually start the division process. Now, with division of polynomials, I want to point out that in the division steps, so remember the 3 steps are divide, multiply, and subtract. So I wrote those over here, divide, multiply, subtract, and then we repeat. Every time, we are only going to divide by the first term here in the divisor. Okay, so that is going to be one unique thing about the division step. So first, I'm going to take the first term here, 2x to the fourth, and I'm going to divide it by x squared. Now we should be comfortable with this because we did monomial division. So x to the fourth over x squared is x squared, and the 2 just stays, so this is 2x squared. Now I'm going to write that on top. Personally, I like to keep track of things by putting the like exponents above each other, or at least starting that way. So I'm going to put it right here. It doesn't really matter. That's just what I like to do to help me stay organized. So that was my division step. Now I'm going to multiply. So what is 2x squared times x squared? Well, that's going to be 2x to the fourth. Whoops. And now the other thing with the multiplication step is we actually have to multiply what we have here by every term that we're dividing by. So 2x squared times 3x is going to be plus 6x to the third, and then 2x squared times 2 is plus 4x squared. So again, this is why it was really important that I write these under their respective exponents here. As opposed to on top, it was not crucially important. It's just kind of nice for organization. But down here below, I have to write these under their respective degrees or exponents. It's also why I needed to put in this space holder for the 0x squared. I didn't know for sure an x squared term was going to show up, but I didn't know that it wasn't either, and I need to put that in. So now we're going to do our subtraction step. So I'm going to subtract, subtract, and subtract. And remember, we can think of this as like a bunch of zeros, so 0x, and then 0 here. So when I do my subtraction, those are going to stay the same. So 2x to the fourth minus 2x to the fourth. And this should always happen. This term should go away. Each term we do a division step, or each time we do a division step within the long division, the term on the far left should always reduce to 0. If it doesn't, then we did something wrong. 3x to the third minus 6x to the third is negative 3x to the third. 0x squared minus 4x squared is minus 4x squared. 5x minus 0x is plus 5x. Negative 1 minus 0 is minus 1. Okay, that was one cycle. Now we do it again. So now I'm going to take negative 3x to the third, and I'm going to divide it by x squared. So negative 3x to the third divided by x squared, and that is going to be negative 3x. So I'm going to write minus 3x. That was my division step, and now I'm going to multiply. So negative 3x times x squared is negative 3x to the third. Negative 3x times 3x is minus 9x squared. And negative 3x times 2 is minus 6x. Now we are going to subtract. So when I subtract here, notice I have minus a negative. Subtract here, I get minus a negative, and subtract here, I get minus a negative. And then this will be minus 0. So negative 3x to the third minus negative 3x to the third actually becomes plus, right? Because minus a negative is plus. So again, this goes to 0, which it should. Negative 4x squared minus negative 9x squared becomes negative 4x squared plus 9x squared. So that's 5x squared. 5x minus negative 6x is 5x plus 6x. So this is plus 11x, and this is still minus 1. Let's do it again. So now I'm going to take the 5x squared. So 5x squared, and I'm going to divide by x squared again. And this becomes 5. So I write plus 5. Now I'm going to multiply. 5 times x squared is 5x squared. 5 times 3x is 15x. And 5 times 2 is 10. Now we are going to subtract. When I subtract here, 5x squared minus 5x squared should go away, and I get 0. 11x minus 15x is minus 4x, and negative 1 minus 10 is minus 11. Now, I would try to do division again, because I'm going to keep going until I can't, but in this case I can't, because negative 4x over x squared is negative 4 over x, right? And so when I say I can't, well, I can do the division, but every time we do this, we don't want to have x's in the denominator anymore. And in this case, I get an x in the denominator. So that tells me, in this case, I'm done. Now, how do I write my answer? Good question. So this up here is what we call our quotient, and this down here is my remainder. So I'm going to write my quotient, 2x squared minus 3x plus 5. So I'm going to have 2x squared minus 3x plus 5 plus the remainder, negative 4x minus 11, divided by our divisor, x squared plus 3x plus 2. So that's our answer. That's polynomial long division. Hopefully you recognize it is a very repetitive process. It's very systematic, but the challenge is you have to stay organized. You have to put the like exponents in columns. When you do the subtraction, it's very important to pay attention to positives and negatives, as we can see, hopefully, especially in a scenario like here where we're subtracting negatives, and we need to recognize that actually becomes addition. But if you just kind of stay organized and follow the process, it's really not that bad. It is long, you know, it's not just a clever name. It's long division. It's not short division. I don't call it that. There's no short division, unfortunately. All right, so that's part 1 of this. We'll do a little bit more practice in part 2.